All right, chapter 19 is solubility and common ion. So it asks you to calculate the pH of a solution made by adding 0.3 moles of acetic acid, all right, so that's a weak acid, and 0.3 moles of sodium acetate in enough water to make 1 liter of solution. So, okay, pretty much we have 0.3 molar of each substance. So major species. So we've got acetic acid, CH3COOH, that's a weak acid, okay? And then we have sodium, NaCH3COO, that is a salt, okay? So what does the weak acid do? We need to write the weak acid, in equilibrium with its ions. Okay, now the salt, unless this is a KSP problem, which it is not, we are going to assume 100% ionizes. Okay, so here's the thing. The weak acid has a weak substance and then really small portions of its ions. It only ionizes slightly, that's why they're weak. But if we introduce a salt that has the conjugate in there, there will be substantial amounts of conjugate coming from the salt. So I'm going to set up my equilibrium expression for the weak acid. Remember, equilibrium expressions are only for weak substances. And then I'm going to go ahead and set up my ice chart, CH3COOH. And something that's going to be interesting is that because we have that should be a minus, two substances present. So we have the weak acid, which is 0.3 molar, right? 0.3 moles divided by 1 liter. Okay, we used to do this, right? 0, 0, we assume it's negligible initially, and then we let x equal something and then solve for x, right? Well, the thing is that there is this guy in here. It's coming from the salt. That's my salt source. The acetate ion is coming from the fact that they dumped salt in here. Okay, so there is 0.3 molar acetate in here from the salt. This is not from the weak acid. And then we just go about our business like we normally would. Let x equal something. So let's let it equal hydrogen at equilibrium. So this is plus x. This is plus x. So now this is 0.30 plus x. This is minus x. So this is 0.30 minus x. Okay, and then I'm going to have to do this up here. Sorry, we'll solve for x. We'll plug back into our equilibrium expression. So we've got x for the hydrogen ion. We're going to assume x is small, is that right? So 0.30 plus x, assume x is small, and then 0.30 minus x, assume x is small, equals Ka. I forgot to include the Ka. It would be given 1.8 times 10 to the negative fifth is the Ka of acetic acid. All right, so then you notice that these cancel, right? And x equals 1.8 times 10 to the negative fifth. So opposite the log of that will give us pH, because remember x is H. And it looks like we're getting a pH of, excuse me. Okay, I don't know what's going on. pH equals 4.74. So look at, if you would have had a weak acid in here, the pH would have been a little bit lower, but we had a weak acid and a salt that had a common ion. So in terms of Le Chatelier, if you add more acetate. You increase the concentration of acetate, which we did by adding sodium acetate. The equilibrium should shift to the left. Is that right? So this is all kind of ties in. This common ion concept also ties back into Le Chatelier, meaning we shift back to the left, okay? We produce less hydrogen ions, which makes it less acidic. Less acidic is higher pH. We have a pH close to 5 as opposed to a weak acid pH of around probably 2 something. Okay, so this also ties in with Le Chatelier's concept. Adding more concentration of acetate shifts the equilibrium to the left. Shifting the equilibrium to the left drops hydrogen ion concentration. The less hydrogen ion concentration you have, the higher the pH the system is. And so this is solubility and common ion.